welcome to The Explainer. So today, we're looking at a completely fascinating geographical mystery, one that pretty much flips everything we think we know about looking at a map. We're going to explore exactly how these massive, invisible forces in our oceans are actually dictating the weather we experience right here on land. Okay, let's dive into this. Think about it. If two places are perfectly horizontally aligned on the globe, sharing the exact same latitude, getting the exact same amount of solar exposure, you'd naturally expect them to have basically the exact same climate, right? Like you'd pack the exact same clothes for either trip. But, well, geography absolutely loves to throw us a curveball. Which brings us to Section 1, the latitude mystery. Just look at this stark contrast. Western Europe and northeastern Canada sit squarely on the exact same latitude. It's a straight line across. Yet Western Europe enjoys this relatively mild, super livable climate all year round. But if you jump straight across the map to Canada, you're plunged into severe, punishing cold for months on end. Same latitude, totally different worlds. So why is that? Well, to find out, we actually have to look past the land itself and look right into the water. Moving right along to Section 2, meet the ocean currents. And this brilliantly illustrates what we're talking about. This bilingual textbook excerpt perfectly breaks down this vital phenomenon. It outlines a really foundational concept that's studied globally, in all sorts of languages. And the core idea is this. Coastal temperatures aren't just dictated by map coordinates. They are heavily influenced by the water actively flowing right next to them. To really distill the mechanics here, ocean currents act like massive, invisible rivers flowing within the sea itself. And the rule is incredibly direct. Warm currents actively raise adjacent coastal temperatures, while cold currents literally lower them. The ocean is basically transferring its thermal energy straight onto the nearby landmass as it passes by. It's almost like a giant liquid thermostat. Let's move to Section 3 and see how this builds. A tale of two coasts. Now, what's really interesting about this is how perfectly it answers our initial question. Western Europe stays so mild because it's constantly bathed by the warm North Atlantic current, which provides massive, vital relief from freezing winter temperatures. Meanwhile, right across the pond, northeastern Canada is totally dominated by the Labrador cold current, and that current continuously blasts the coast with icy, freezing water, which is what causes that prolonged severe cold. So identical latitudes, sure, but completely opposite ocean currents running past them. Which brings us to our final section, Section 4, the unseen climate regulators. So the crucial point we really want to synthesize here is this. Latitude alone simply doesn't tell the whole story. It's just a starting point. Warm ocean currents are the real mechanism for temperature relief, while cold currents are what inflict that severe cold. Ultimately, you just cannot fully understand a coastal environment without looking at the water flowing right beside it. That's where the real story is. I want to leave you with a final thought today. We so often look up at the sky to understand our weather, but man, we really need to be looking out at the sea. The next time you check the weather on the coast, ask yourself, what invisible current is shaping your day? Thank you so much for joining me for this explanator, and I will see you next time.